In this video, we're going to talk about how we can use probability to find proportions in a frequency distribution. So we're going to talk about probability and its relationship to the properties of the frequency distributions that we've been talking about since really lesson 2. We talked a little bit more about some concepts in lesson 4 and 5 that are going to come into play in this lesson. All right, so frequency distributions, they can be seen as representing the whole population. It includes all of the possible values. And different proportions of the graph represent different portions of the population. So portions of the graph will correspond to the probability of the population. This might not make sense yet, but hold on. This is something to remember, that when we talk about proportions and probabilities moving forward, we're going to see these as the same thing. Proportions and probabilities are going to be equivalent. All right, let's do a little bit of practice looking at the probability or the proportion of a frequency distribution. So this might look familiar to you. We've done something with this type of distribution before. This particular population has 10, at n of 10. If we take a random sample of one score, what is the probability of obtaining a score greater than 4? So I want to point out to you the notation that we're going to be using. So P means probability, X is our score, and we're looking for X that is greater than 4. So what is the probability of finding a score that is greater than 4? That's how we read this. Well, try to figure it out first on your own. Pause the computer if you need to. The probability is actually 0.20. How did I get that? Well, the event that I was interested in are scores greater than 4. What are the scores that are greater than 4? Well, it's 5 and 6. How many scores greater than 4 did we have? We had two boxes, 2 scores. How many scores did we have altogether? We just have to add up all the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 2 scores that were greater than 4 divided by the total possible of the scores, and that gave us a probability of 0.20, which can be written as 2 out of 10 and can be interpreted as a 20% chance of choosing a score that is higher than 4. So when we do the z-score transformations that we talked about before, proportions can be assigned to specific sections of a frequency distribution. And that means we can assign proportions to the population. So let's take a look and see what this looks like. This will look familiar to you. We have the normal distribution, and what we've talked about before is that there are 68% of the scores between -1 standard deviations and +1 standard deviations. Well, this graph just breaks it down a little bit more, 68% divided into 2. There's some decimals there too, so we've always said it's about 68%. So what this tells us is between 0, the mean, and 1 standard deviation, we have 34% of the scores. And between 1 standard deviation and 2 standard deviations, we have about 14% of the scores. And between 2 standard deviations and the remaining portion is about 2%. So we can assign proportions to this normal curve. Now, what happens if we add up everything that's to the right of the mean? We have 34 plus 14 plus 2. What does that give us? It gives us 50. That's 50%. And that is true because we know that the normal curve is 50% above the mean and 50% below the mean, right? So if you add up 50% and 50%, you have 100%. You have all the possibilities in the distribution. So we've just done this, add up all the values on the right side of the distribution, the total is 50%. All right, we're going to play with this a little bit. With what we know about the proportions of a normal distribution, we can determine the probabilities for specific events. So let's talk about height. Let's just say that there's a normal distribution of height and 68 inches is the mean. So what is that? 5 foot 8 inches is the mean. And the standard deviation is 6 inches. right? So those are the parameters of the population. What is the probability of randomly selecting an individual from the population who is taller than 6 feet 8 inches? In other words, 80 inches. That's the conversion. So the score is 80. So let's take a look at the notation. What is the probability of finding a score that is greater than 80? That is what we're going to use. We're going to use our information to figure this out. So we have a mean of 68 in the population and a standard deviation of 6. The height score I'm interested in is 80, and I need to find the z-score in order to figure out where it is in the distribution. So my z-score formula is the score minus the mean divided by the standard deviation. So I have my score of 80 minus the mean of 68 divided by the standard deviation of 6. 80 minus 68 is 12 divided by 6, which gives me a z-score that's equal to 2. Now I like to draw this out to see where this z-score is. So let's do that. So here's my roughly drawn normal distribution, and my z-score was a 2 for 80 inches tall. And I said I was interested in the percent or proportion of people that were greater than 80 inches. That's this area right here. This is the area I'm going to be interested in. So it's pretty unusual to find somebody with 80 inches or taller than 80 inches, correct? All right. Okay, so here it is mapped out. I have the raw scores on the left and the z-scores on the right. And we have that z-score of 2 that we found. And we know that beyond a z-score of 2 is about 2% of the population. So the chance of drawing somebody who is 80 inches or greater is about 2%. It's a pretty rare event. When we have events that are happening in these little tail areas, we consider them to be pretty rare. 2% is not very common, right? So that probability is about 2% that we would randomly select someone taller than 6 feet 8 inches. We're going to use what's called the unit normal table, and this was right above this video. Hopefully you have it out. If you don't have it out, you might want to get it out for the rest of this video. The unit normal table lists the relationships between z-score locations and proportions in a normal distribution. So for any z-score, you can look up the assigned proportions, and using only proportions, you can also look up for a specific z-score, so you can get information one of 2 ways. So this is the unit normal table. I want to explain it to you. In the left column, you have all of the possible z-scores, and in the second column, we have what's called the proportion in the body. So take a look at the illustration over here. This column will tell us the proportion that is in the body of the distribution. In other words, it starts somewhere on one side of the mean and extends all the way to the tail. It could go the other direction as well. So we have positive and negative z-scores. Your z-table only lists positive scores, but that's okay. We can just use them for negative scores too, because the distribution is completely symmetrical. So for example, if I had a z-score of 0.29, that means that 61% of the distribution would be between a z-score of 0.29 and the tail, the rest of the tail, the body. So when I think of the body, column B, I think of it as something that crosses the midline. It starts on one side of the mean and goes all the way to the end of the other. All right, that's column B. Column C is the one we're going to use quite a bit. This is the proportion in the tail, because we're going to be looking for events that are very unusual in statistics. And column C shows us the proportion in the tail, or how much is in this tail area. The last column, column D, is going to show us how much is between the mean and some z. That z might be above the mean, that z might be below the mean. We can use this table for positive or negative z's. And the same goes for the tail. It might be on this side or it might be on this side. Doesn't matter. We just take the absolute value of the z. All right. So what I want you to do, you have your unit normal table, hopefully by now. I want you to find a positive 1, a z of plus 1 in the unit normal table. Now again, it's not going to say plus 1 because it shows 1 whether it's plus or minus. Just find a z of 1. Then I want you to tell me what you notice in the column D. Okay, I have a unit normal table here. I'm going to go ahead and circle a z-score of 1. The z-score is in the A column. Then I'm going to go ahead and circle the D column figure, which is 0.3413. Well, there it is. A z-score of 1, a standard deviation of 1, is equal to 34% of the distribution between the mean and a z-score of 1. That should look familiar to you. I'm going to have you figure something else out too. What if you add up the proportion in the body and the proportion in the tail at this z-score? What do you get? You get 1.0. You get the whole distribution because what's not in the body is going to be left over in the tail. What if you add up column C and column D? What do you get? Well, you get 50%. You get 0.50 because if you add the proportion between the mean and a z and then what's left over in the tail, that'll give you 0.50. Think about that. Play with it a little bit. So in the D column, we had 0.3413, which is the same as 34.13%. So right here. So that is how the z-score tells you exactly the percentages at different points. We used column D, which was the mean between the mean and a z. So it's this area right here. All right, we're just getting started. Percolate on the unit normal table, think about it a little bit, and I'll see you at the next video.